George Washington died without a single direct heir, leaving his true genetic ancestry a mystery for more than 2 centuries. But in March 2024, scientists finally broke through, uncovering DNA evidence from long-forgotten family graves that reshaped what we thought we knew. What they found revealed not just Washington's origins, but a hidden thread woven through American history. How could a missing bloodline transform the story of a founding father? Washington's personal life held a mystery that puzzled generations. He never fathered a child. After marrying Martha Custis in 1759, he raised her 2 children from her first marriage as his own, but the couple had no children together. The cause has never been definitively settled. Some historians point to a severe bout of smallpox in his teens that may have left him sterile. Others suggest a congenital condition. No surviving medical record resolves the question. But when Washington died at Mount Vernon on December 14, 1799, one fact was clear: his direct bloodline ended with him. This created a unique challenge for modern science. The key to tracing a man's paternal ancestry lies in the Y chromosome, passed from father to son and remaining largely unchanged across generations. It is a genetic thread that can stretch back thousands of years, but only if the line remains unbroken. With no sons or grandsons, Washington's Y chromosome seemed lost to history. For more than 2 centuries, that missing link kept his deeper ancestry out of reach. Genealogists relied on paper trails, wills, land deeds, family Bibles, but documents cannot reveal ancient origins embedded in DNA. The very code that defined Washington's paternal line appeared locked away by the simple fact of his childlessness. Yet the story did not end there. Washington had 4 brothers, all of whom carried the same Y chromosome inherited from their father, Augustine Washington. If any of their male lines survived, science might still recover the lost thread. The search for Washington's ancestry would depend not on his own children, but on the descendants of his brothers. In 1999, a quiet excavation at the Harewood Family Cemetery in Charlestown, West Virginia, sought to recover remains linked to Samuel Washington and his descendants. Archaeologists uncovered 5 unmarked graves and retrieved bone fragments and teeth from 3 of them. At the time, DNA technology could not unlock the secrets held in those fragile remains. The samples were too degraded for analysis and were carefully preserved for the future. That future arrived in 2024. The Armed Forces Medical Examiners System, through its DNA laboratory, AFDIL, applied advanced techniques developed to identify fallen soldiers from severely degraded remains. Using hybridization capture, scientists isolated tiny surviving fragments of genetic material. Next-generation sequencing allowed them to read and assemble these fragments, scanning markers across the Y chromosome, mitochondrial DNA, and more than 95,000 nuclear SNPs. But technology alone was not enough. The breakthrough required a living link. A direct male line descendant of Samuel Washington stepped forward and provided his DNA, creating a bridge across centuries. Researchers compared his genetic profile to the ancient remains, searching for confirmation of identity and continuity of the Washington Y chromosome. The results, published on March 28, 2024, confirmed that the remains belonged to Lucy Payne Washington and her 2 sons, grandnephews of George Washington and direct paternal descendants of Augustine Washington. Every critical Y chromosome marker aligned. The unbroken male line from the 18th century to the present was confirmed. The Y chromosome, once thought lost with George Washington, had survived in the descendants of his brother. For the first time, science could identify the genetic signature of America's first president. Washington's Y chromosome belongs to haplogroup RU152, a lineage that emerged roughly 4,500 years ago during the Late Bronze Age in Central Europe. Today, this lineage appears most frequently in regions around the Alps, modern Switzerland, northern Italy, and eastern France, with lower frequencies spreading into France, Germany, and England. Ancient DNA studies have identified RU-152 in burials associated with the Hallstatt and La Tène cultures, societies linked to early Celtic and Italic peoples who flourished before the rise of Rome. Known for ironworking, trade networks, and distinctive art, these cultures shaped much of early European civilization. Washington's paternal line traces back through that same ancient corridor. The same genetic markers found in his lineage have appeared in Bronze Age graves across Central Europe and in medieval burials in Italy. The discovery places the first president of the United States within a much deeper prehistoric European narrative, one defined by migration, alliance, and cultural transformation. Another remarkable parallel emerged. Abraham Lincoln has also been identified as carrying the same broad R1b lineage, linking both presidents to ancient European paternal roots. One led the birth of the nation, the other preserved it. Their shared deep ancestry underscores how intertwined human histories truly are. Other historical figures connected to the RU-152 lineage include members of the House of Habsburg, as well as figures such as Johnny Cash and Robert Burns. Though separated by centuries and continents, their paternal lines converge in the same prehistoric European migrations. The Washington study revealed another unexpected twist. When researchers compared the DNA of historical and living descendants, some relationships appeared genetically closer than traditional family trees predicted. The explanation lay in repeated cousin marriages within the extended Washington family, a common practice among colonial elites. Over generations, shared ancestors appeared multiple times in the pedigree, creating what geneticists call pedigree collapse. This compressed the genetic distance between relatives. One more layer emerged from the analysis. While the overwhelming majority of the Washington lineage reflected European ancestry, researchers detected a small trace of African ancestry entering through the Payne family line. Lucy Payne Washington's family was connected to prominent early American figures, including her sister Dolly Madison. These intertwined families reflect the complex and often overlooked threads woven into early American identity. In the end, the DNA does more than trace the ancestry of one man. It reveals how the story of a founding father connects to ancient Europe, to other American presidents, and to the broader human past. The evidence reshapes our understanding of heritage. Less myth, more measurable history. With every advancement in genetic science, history deepens. The past is not fixed. It is still being uncovered, strand by strand.